Hello again. In this short video, we're going to talk about don't care conditions in K-math. It is quite common to see situations where input combinations does not have certain input combinations does not have an impact on the overall system output. Like for example, what we are saying is, look at this truth table here. What we are saying is, in a system, these two inputs does not have any impact on the overall output. The output has a 1 or a 0, it doesn't affect the overall performance of the circuits. So we use this logic to optimize our circuits even better, and what we do here in the truth table is conditions like this, we mark them with an X here, and we use them to optimize our circuit even more possibly. So let's see how do we optimize a circuit for a function like this. So here we have a problem. We're given a function for inputs w, x, y, z with an output of f. We're given summation of minterms. So when we see summation of minterms 0, 1, 2, it simply means it is m0 plus m1 plus m2. So if you see summation of don't cares 3, 4, 7, it simply implies don't care 3 plus don't care 4 plus don't care 7. So here we have summation of minterms 0, 1, 4, 13, 15. So let's look here. 0, minterm 0 is right here, so I write a 1. Then minterm 1 is on the left, so I write a 1. Minterm 4 is right here, and minterm 13 is right here, and minterm 15 is right here. So let's see here. If I were to follow the traditional way and group them together, let's see how many groups we would get. We would get a group of 2 here, we would get a group of 2 here, and we would get a group of 2, and so essentially my function would be group 1 plus group 2 plus group 3, and each group would have about 3 literals here, and 3 literals plus 3 literals, so it would have a total of 12 literals here, and which is not the simplest solution here. So let's see here, how do we come up with a circuit that is even better? So let's see here, we looked into minterms. Now let's add the don't care conditions. The don't cares go, don't care 5 is right here, the don't care 9 is right here, and the don't care 11 is right here, the don't care 12 is right here, and don't care 14 is right here. So what we are saying when we talk about don't cares is that the don't care could be either a 0 or it could be a 1. So we'll presume the don't care as a 1, and we'll try to use that in our grouping. Now let's look into forming two groups here. Now try to identify the largest group. Here we have one group of 4 ones here. Now we have 2 ones, and this could be a 1, this could be a 1, right? So what I'm going to do is I'm going to group this also as 4 ones, right? And I'm going to call this as group 1. I'm going to call this as group 2. Now we have 2 don't cares, and we don't care about, these are just 2 don't cares. All what you need to do here is make sure you cover all the ones. It doesn't matter, since these are don't cares, it doesn't matter if you combine them or do not combine them. So let me call this as group 4 and call this as group 5 for now. So I'm going to have my function as group 4 plus group 5. Let's talk about group 4. Group 4, let's look here. My W is 0 here, W is 0, W is not changing, so I'm going to write W bar. Now comes X is 0 here, X is 1 here, X is changing, so we disregard X. Write about Y is 0, Y is 0 here, so oopsie, my Y is 0 here, Y is 0 here, it is Y bar. And now y bar, and z is 0, z is 1 here, z is changing, so we disregard z. Then comes to group y. My w is 1 across these 4 cells, so we write w. My x is 1 across these 4 cells, we write z here. Now y is changing, y is 0 here, same, but y is 1. We disregard y. And z is 0 here, z is 1 here, z is changing, so we disregard z as well. So overall, we went from a function to just 4 literals. So as you can see, if we do not care about don't cares, we end up with a function of 12 literals, and when we considered the don't cares, we went to a function where we came up with just 4 literals. So using don't cares will definitely help us optimize our circuit better. Thank you.